Find the invariant lines on the transformation given by the matrix M1103. Okay, so the invariant lines are going to be of the format y is equal to mx plus c, because that's the format of equation of a straight line. So our new coordinate, x dash y dash, will be 1103 times any coordinate xy. If we multiply that, we're going to get x plus y, and then in the row times column, we're going to get just 3y in the bottom. Now, but y is equal to mx plus c, so we'll replace y with mx plus c. So we've got x plus mx plus c, and then 3 times mx plus c. Simplifying that, we're going to get x plus mx plus c, and then we're going to get 3mx plus 3c. As the line is invariant, this point must be on the line as well. So therefore, we're going to say the y value, 3mx plus c, 3c, is going to be equal to m times the x value, x plus mx plus c. And then add another c on the end there. Okay, so we're now going to simplify this. So multiplying out the bracket first of all, so we've got 3mx plus 3c, you're going to have mx plus m squared x plus mc plus c. And we're now going to put this equal to 0, so we're going to have m squared x. And then if we bring them up 3mx over here, we're going to just get minus 2mx when we combine it with that one. And then we're going to get cm and then minus 2c. Okay, so we'll factorize this bit here. We're going to get x m squared minus 2m times x, and then here we're going to get m minus 2 times c. So hence m squared minus 2m must be equal to 0, and also m minus 2 must be equal to times c must be equal to 0. So if we say this is equal to 0, we're going to get m, and m minus 2 is equal to 0. That gives m is 0 and m is 2. And here we get the same value. M minus 2 will be equal to 0 when m is 2. But c can take on any value because this will be 0 in this particular case. Not in this particular case. In this particular case, it will actually be equal to 0. Okay, we can now say, hence, m is equal to 0 and c is equal to 0. That gives a y is equal to 0, because m and c would have to be equal to 0 in this case, because m is not equal to 2. But when m is equal to 2, our line can become y is equal to 2x plus any constant, including 0. It can be any constant. So the invariant lines in this case, under the transformation, are going to be y is 0 or y is equal to 2x plus c. Now, if we go to this GeoGebra app, which is also in the notes of the video, okay, we can see that b, for example, has gone to b dashed. We can see that d has gone to d dashed, and we can just about see the point C here has gone to C dashed, and then we can't really see, but A has gone to A dashed. But the interesting thing is here, this blue line, because it's 2x plus a value of C, can take on other values. We can do this by looking at the slider here. Let's just try and find a nice value where we can see everything. Okay, let's take that one down there. Okay, we can also see here that D has gone to D dash, and then B has gone to D dash, and all the points on the line, red line, had stayed on that line. Okay, so there'll be an infinite number of solutions for the blue line. Okay, just remember if you're using the app to reset the slider, if you're going to change the values in the original matrix, make sure you reset the slider. Okay. So, and then you'll get the set of solutions here as well. So this app I will put in the notes of the video. So this has been a video to show you how to find invariant lines under a transformation where necessarily the C is not non-zero, okay? I hope you've understood, and thank you very much for watching.